I'm Dale Hersman, and I'm here to present for Crops TV today. And the title of my presentation is Exploiting the Iowa Environmental Mesonet for Fun and Profit. So I like to keep things free and loose and running here, so I hope we have a little bit of fun, and hopefully we can make some profit, since time is money. If you can save some money by finding products and data that you need more quickly, then maybe you have profited by watching my presentation today. So for the next hour of your life, don't be too excited here, but we're going to be talking about the Iowa Environmental Mesonet Project's introduction, what this project is, and why you should be wishing to use it. I'm sure many of you have already used the website once or twice, but you're here hoping for some more information about where actually to find things, and so that's what we're going to try to do. So we'll give a little bit of website organization and navigation, try to get in my head here actually about how I set things up, so maybe you can figure out how to find things too. And then hopefully the meat of the presentation today will be the profiting by being able to quickly do some 8 common tasks. And so I've picked up or organized here 8 common things that people come to my website for, and I hope that with an ag emphasis, of course, and hopefully we can just go through those quickly, and I'm going to show the end-to-end workflows of moving stuff from the website into Excel or doing whatever with it. So hopefully you'll enjoy that. And then if I go quickly or have some fun, we can do some fun things at the end too. So we'll see how it goes. So you have to cooperate with me here if we want to have fun at the end. So I'm Daryl. I'm in staff here in agronomy. I just have a bachelor's degree in meteorology, so that's kind of lame for an academic. But anyway, back in 2001. So ever since I graduated with my meteorology degree, I've started this project and kept it going ever since. So I'm the proprietor and the only employee basically of the website. And I'm here because obviously the folks here on this presentation are my main audience, the ag sector. And so we're an ag state, and so a lot of the products that I have are geared toward usage in the ag sector. So when people come to my website, I think they get this strange mentality or idea about what is the world is going on here. I mean, it's acronym soup for one, but you just find endless places to find data and tooling and visualizations and all kinds of stuff. So it's kind of I don't know how to describe it, but it's been a lot of fun these past 21 years. And basically it's a result of having all of you contacting me and sending me ideas or what you need for weather and climate products, and I just basically implement it. And so that leads to a lot of feature sprawl on the website. And I list out here, we got about 150 apps and 30 some download portals. And we'll show you the automated plotting tools that exist now. And there's 230 of them as I write this, and it grows about every day. So the virtuous cycle here is to atone for these things. I have to come here and do presentations or to explain a website away, which is sort of a lame thing to do in the year 2022. But also I mentioned that I will promptly answer any emails you get. And then if you send me suggestions for what you aren't able to find or struggle to do on the website, I'll probably fix that. And of course, we repeat the cycle. And I'll probably be back here again in 10 years trying to explain what's still going on the website. So which is fine. So the high level view here for what's going on with the IEM website is that the M in the acronym stands for Mesonet. And most every state and research institution has some sort of form of Mesonet. Most states are much bigger than ours, and they have actually staff. I'm technically not necessarily staff on this project, on a project that's sort of like a project that I maintain with other funding as well. But they also have deployed equipment and research programs, and that's what they deem as a Mesonet. The Iowa State University has what's called a soil moisture network, which is sort of like a Mesonet project. And some call it the Mesonet, so they use my website's abbreviation in that term interchangeably, but they're not actually the same, and they're different projects. But the data from the Soil Moisture Network is found on the IEM website, so that makes everything fun and confusing, to say the least. And so I'll try to clear up some of that today too. So let's take some time to go tool around the IEM website. So here's the state of my website as it exists today. This on a Friday, December 16th, 2022. Every day, the most pressing or prominent thing you see on the website is a daily feature. And so I try to post something every day that has some relevance to the current weather and climate, to keep people, coming back. It's a way to drive traffic to the website. But today's map is a analysis of available snow reports so far this morning. And then I usually produce a little bit of a narrative which each of the maps. So you're welcome to come to the website every day if you wish to view this, but you also can subscribe to like RSS feeds and other means to keep just you don't have to look at this every day. But of course, the fun thing, of course, what I try to keep always have fun on the website is to have the links at the bottom where you can vote either good or bad or abstain. And so that's always been a tongue-in-cheek sort of thing, that you can abstain if you don't wish to vote good or vote bad for a certain day. So I always encourage you to come in, click that good button, right? But you don't have to. But anyway, so on the website, we try to keep the Iowa State look and feel. The primary means of navigation up here is this nav bar with my logo. And of course, anytime you click on the logo, you come back to the home page. But the various drop downs here have items of interest. And so we'll go through some of these today and talk about what data and products you can find underneath many of these, and how to go have the mentality I do when I go to look my own products, my own website to find things. And then the networks tab is an important one. The IEM website organizes observational data into what I term as networks, which is basically a collection of spatially and consistent platforms that are reserved by or organized by a certain group. For example, down here you'll find the ISU Soil Moisture Network, or the NLA Flex Station, or the Roadway Weather System, which is the Iowa DOT, and all sorts of other things here. And we'll talk a bit more about those later. But as you scroll down the website, you also find the other key section here, which is called the most popular section. And in here is some of the many things I'm going to highlight today, including the automated data plotter, the ClimateDat reports, the IEM Explorer, and other sorts of tooling as far as downloading like rainfall and GIS formats and other things. I have a new section, again, where I post more long-form things about changes on the website, interesting things. Again, there's an RSS for that. Down and at the bottom, there's three main plots, just to highlight. And I sometimes swap these out during this season of the year to what's interesting at the time. So I want to start off with some showings under the info tab. There's a station data and metadata section. And here you can sort of start drilling down into what networks we have available. And you can scroll and scroll and scroll. I try to collect data pretty much for everywhere I can find it. So if you ever wanted data from the Maldives, you can find it here. But so within each network, though, you'll see a collection of stations. And so if you click on one of these stations, you can see its aims and then select it, and we start going into more data portals. And we'll come back to these data portals in a little bit. The next one I want to point back, and again, we'll just sort of keep always clicking back to the home page and then starting a new navigation trip. But if we go to info and then down to variables, we come up with this nice table where I try to organize which variables are being collected from which of these networks, and the acronym heavy, networks here. And so, for example, if you're looking at something like soil temperature, you'll find that there's only 2 networks that have this type of data, including the ISU Soil Moisture Network and then the Soil Climate Analysis Network, which is an NRCS USDA network, and so on and so forth. But you can click on the networks to go to the network main landing page and get more information there. Another neat tool on the top is this search bar. Now this got a little bit of an awesome bar capabilities to it, but you can put in some specialized search strings and get back results. But one of the things you can put in is if you know your station's acronym, for example, or station's identifier, so the Ames Airport, which is AMW, if you put AMW in there, you'll get back, let's try a different one actually, AMSI4. I put in AMSI4, which is the weather station that's at the ag farm that's part of the NWS cooperative network. You can just put that identifier in and it takes you right to the station. So that's one of the neat ways you can quickly get through the website if you know some things ahead of time. And then finally, I just want to show the networks table option. And again, this is another way to list out which available stations there are and some brief metadata about when archives start. And if the archive is blank, then of course it's online at the moment. But for example, I can click on here in Cedar Rapids and there's Cedar Rapids airport data. Okay, so that was just a brief tick through of brief organization overview of the IEM website and what I'm trying to accomplish there. Now go through 8 tasks of things to do on the website that hopefully you can have fun and profit with, as the title says. So the first one I show is the IEM Explorer application. Now this is an app I recently wrote to support a display I had at the Farm Progress Show. And what I'm trying to do with it is provide an easy way to get you spatially into where we have data and be able to find a nearby station to your location. And again, we click on the IEM to go back to the home page. The IEM Explorer application can be found right here under Most Popular. It's also linked in other locations. It's meant to this page is meant to be like sort of a kiosk display, but it has some interactivity now that's useful for you. But the immediate thing you see here as we come with the Iowa is a whole bunch of dots and different colors things. Now, the ones I want to point out today are the green dots, which are the locations that we have long-term climate data. So these are locations that are currently online, but have data that goes back at least 50 years. So a lot of times when you want to look at data over long periods of time, of course, you want to try to get it all from the same station. Now, automated stations and manual stations come and go. So it's not the case that you have just thousands of these. So all these green dots are basically the only locations in the state where we have at least 50 years of data for a given location. But as you can go through here and zoom in and zoom out, whatever, the other sorts of icons you see, including the ISU little icons here, are where we have weather stations at mostly the experiment farms, but also some at vineyards and other places. The blue ones here are specialized spatial averages for the climate districts, or the crop reporting districts, some might call it. And so I produce spatial estimates of rainfall and temperature that you can then look at changes with time, wherever, for larger scales. And I'll show an example of that later. Also, you'll see the airport icons. These are where we have mostly the state or the FAA has automated gauges at automated weather stations at the airports. Now these are meant to help land and allow airplanes to take off. So they're not necessarily have an ag focus to them. For example, you don't find solar radiation data with this or soil temperature data with these stations because it is not a necessary variable to help land airplanes. But you find things like atmospheric pressure and highly reliable wind data, which of course is very important for airplanes. So the thing I want to just take away from here is that we want to use this app to go and look for what's nearby to our location. Now, for a number of the tasks that I'm going to show today, I'm going to focus on an area of Northeast Iowa where I grew up, way up here, up in Clayton County, and just look at what's around me. So my mother's farm is currently somewhere in here, North Vilcator, and so you see the nearby options to look at. So we have a long-term climate site in Postville, a long-term climate site at the Osborne Center near Elkader. And then if we go across the river, we got something over in Prairie du Chien, including an airport weather station in Prairie du Chien, and also an airport station up here in Decorah. And of course, the Decorah one I like because the acronym for Decorah is my abbreviations of my name, including my middle initial. So that's always fun that I grew up next to that station. But anyway, but the neat part about this tool is that it allows you to see data across states too. So a lot of times in my website, you only can see data within a certain state at a certain time. So this helps you identify where data is available. So the key one I'm going to point out here is that we're going to focus on Postville when we want to look at long-term climate data. And I'm going to pick Decorah for when I want to look at automated weather station data for like wind and stuff like that. Now, I want to point out that if you're going to consult my field notes that I prepared for this, I do go into a little bit of discussion about these different type of network types and which ones you want to be picking for certain variable types. And we'll go through that a little bit as we step through things today on the task. But this website has a little bit of tooling built into it. So if I click on one of the stations, you get back a set of things that I focused on at the Farm Progress Show, but also just in things that are relevant in general that you can quickly get to and see. And it builds these interactive, nice charts that you can play with to look at things like climate change aspects, look at properties of the 1930s versus the 2010s. So neat visualizations. But you also can exit out of these with this first link with the site's main page, which takes you back, or I can actually do it and I'll just show you. It takes you back to the main landing page for the web for that station. So it's an index way to get around on the website. Now these plot types and stuff you listed here, they're just a subset of what's available on the website. So that's what you can find for like the co-op stations. If I go up and look at one of the weather stations that have whether you're at the airport, you get a whole different suite of products, including things like with wind information and also wind roses, which we will talk about later. The other aspect on this website is just a quick overview of certain maps on the side of interest. Again, these are sort of quick hitter things that you can find more information about if you click on it, and then they'll give you deeper links into the website. So that was task one. We survived and we're on time yet, so we're doing pretty good. I just want to show off the IEM Explorer and how you can find your local stations and keep those, stations. Either, you can write those station identifiers on your hand if you want, just to keep them forever, or just try to keep in mind what those names are as we go through other tooling on the website to know where you can find data next to you. TPS reports. Office space fans hopefully are enjoying this right now, but in this context, I'm going to say TPS means temperature, precipitation, and snow. So my task I'm going to give you right now is go on the website and determine what the June 2021 temperature total and departure from average was. So how do we do this? And we're going to go back to the home page. Now, for those of you that have been around a long time, including that have heard speakers like Dr. Ellen Taylor and Dr. Richard Carlson and before, this product predates me by, I think, 20, 30 or some years, but they call these reports Climodat. And so this presence has been around since we've had internet capabilities at Iowa State to have these reports available for people to use. And so again, this is one of the most popular things we have. So under the most popular, we find these Climodat reports. And so you come into this portal, and again, now we see dots I'm mapping it, but there's a lot more dots. And let me explain why. In this case, what we have is we have all the long-term climate data that's available in the state. A lot of these stations, the ones that you're seeing here in yellow, are ones that are currently not reporting in real time anymore, which means the station has been discontinued. Now, just the backstory here is that this data is coming from human volunteers associated with the National Weather Service, like cooperative observers. Now, these humans, unfortunately, get old and they move, or unfortunately, most in cases when these stations go away is that they die. And then the Weather Service, sadly, has to try to find, somebody locally that wants to try to take this data as a volunteer. They're not paid at all. And so it's been difficult. And so it's always a challenge to keep these stations going due to those reasons. And also to maintain a long-term archive is very difficult. Now, the major city locations in the state obviously have better opportunities for us because there's more people there, more opportunities to keep stations going. But the green dots are the ones that will have data in near real time. So if we zoom back up in here to Northeast Iowa, and again, there we find Postville again. So we're going to focus again on Postville. So I clicked on the map to find Postville, which changed the selector up here to Postville. Or the other option you can do too is you can just doom scroll through all these different sites that has their name and then the period of record for each site. Or you can go up here into the search bar and start typing Postville, and it filters back out. So there we go. We got to Postville. So that we're selecting the station, and the next step is to select a report. And so in this case, we have these different various reports that are organized by data type: precipitation, temperature, growing season, and snowfall. But we want monthly and yearly precipitation totals. So we click on this, and then we click View Report. All this is being generated on the fly, so it should be valid up until the current day with the data. But in this case, what we see this nice, 1970s style ASCII table of data that includes monthly precipitation totals. Now, these starred locations here are when the station was not yet online or has all this has missing data. But what we see here is the June column. So we were interested in getting June 2021 data for precipitation total. So we just scroll down through here, June, 2021. There we are, 6.88 inches. Now, immediately we find below this, we find the mean column, which is basically just the arithmetic mean of what the data in this column is. And so it says 4.81 inches. So for this month, we're about just over 2 inches above normal. So in this case, we could be done. But I would like to point out that there's a little bit more functionality here. Let's say we want to do some more with this data file than just get that single point. What you can do is you can download this report as an Excel file. And so we're going to try doing that and see how this goes. So I clicked on it and we see that a file downloaded called iem.xls. And we click on it to load, and we're going to watch the joys of Excel loading. And then there we go. So there, now we have all that same data in Excel, and we can do something simple, like, well, I think we can. I don't play much with Excel, so I apologize. So we're not going to, I guess. So this June column, again, we go down and look. There we are. We should have the same value, 6.88 right there. Now, in this case, we don't have the arithmetic mean total showing up here, so that's an option, we can actually put in here. We do average. And we do G2 through G131. Yeah, there we go. And so there we are. So there we're back to that arithmetic mean for the total for that month. And that was that task. And so we have completed task 2. So we're going to keep going though. Task 3, growing season totals. So a lot of people would like to create maps or get the raw data for some weather station for a period of days. So you might have some experiment going on, or you just want to know between when you planted and when you harvested, what you got for growing degree days and what you got for precipitation totals. So what we're going to do is we're going to go on the website, show how to create a map of this 22 April to 22 September total precipitation for this year and then for 2012. And we'll scroll back up and we're going to go to the main page again to show you how to get this. And in this case, my mentality here for the navigation is we have an ag weather type of request here. So we'll go into the ag weather tab, and then we're going to go down here and look. In this case, we're going to look at the precipitation totals, and then we're interested in a seasonal or a monthly, weekly total. And then we're going to look at this map of totals application. When we click on that, it takes just a little bit to load because it actually is computing a default range of data for May to October. So while that's loading, I'll just point out some of the other things. There's a lot of different deep links here to look at various variables at different timescales. Now, the thing to point out here is when you're interested in certain variables, like temperature at hourly intervals, that changes what data is available, because that climate data, that once daily observations obviously will not have hourly information. You have to go to an automated weather station, and typically you want to look at the airports for that. But if you want something even finer resolution, like down to every minute or even every second, then there's even different options there as far as what is available. The ASOSs do have some of that data, the airport stations, but the soil moisture network is usually the most reliable for that type of a time scale. And we can look at other things too. And the page finally updated, so we're going to take it now. So we come into this portal is where we're going to have maps of growing degree day totals, or I'm sorry, precipitation totals we're going to do. And we can also do a growing degree day total too, since I'm presenting and control the time here. But anyway, so what we want to first do is we're set on Iowa, good. We can go to other states if you want, but we're going to focus on Iowa today. And precipitation, 2022 we said, and we want to do April. And we want to go to 22. And we're going to go to, I think it said September 22, if I have my notes right. Yeah. And within the field notes too, I go into a little bit detail about what this map is showing, or what you should be taking into mind when you use a map like this. And a lot of times what you end up seeing is you'll see a lot of really fine scale detail. Now, precipitation and temperature will have fine scale detail for different reasons. And for precipitation, obviously, you'll see fine scale detail because individual thunderstorms will bias the representativity of a given station to what you can see are how far away its data is applicable. But as you go out and basically integrate with time, as you go further and have longer windows of time, that variability starts to wash out. So hopefully some of that station to station variability you see at shorter timescales washes away. And so that's why at my mom's farm up here, in middle of Clayton County, I can probably use the data for post-fill for a growing season and have some confidence that it's fairly representative to my location. So again, the data here on the map is actually showing the value 26.89 inches for the per period. But down here below, I just want to point out that all this data is represented in this nice little ASCII table. And I'm going to show you guys a crazy trick today of how to get this into Excel, and it's actually sort of convoluted. So I hope you enjoy this. So what you can do is you can copy this table, copy, and now what we have to do is we have to go to Notepad and Windows, and we have to paste it into Notepad. And now we need to highlight it all again and copy it again. And we're going to go back to Excel and see if I can struggle with Excel for twice in one day and do a blank notebook and go to the paste option and go to text import wizard. And now we see a wizard that's basically talking about how is this data that's currently in your clipboard, or basically what you copied from the notepad, needs to be imported. And so we're going to call it, it's still limited because it's comma separated. And so we're going to select comma here. And it's not space separated. So, and we go next. And we can just finish now. And there we go. All that data has now been imported into Excel, and we can go on our merry way and go to town, so to speak, on Excel. And these variable names up here can be somewhat cryptic, but hopefully they make a little bit of sense. And of course, the precip is the total for the period. Now, there's other ways that you can download this data too, but I just wanted to show this one neat little trick to get data from the website into the Excel. Okay, and I think that ends the discussion. Again, I want to point out to look into the field notes to look some more details about this whole process for these maps, because they go into a little bit more discussion about why the variability exists. Oh, we didn't do 2012 yet, so let's go back and do that quick. So all you have to do for 2012 is then just change the year 2012 and make a plot, and then go get a cup of coffee because its website's running a little slower at the moment, but it'll generate when it comes up. I guess I'll talk to really briefly while we're generating about this variability issue. So I mentioned about precipitation being variable because of thunderstorms. The thing to realize is that temperatures can be variable too because of things called microclimates. Now, we think that Iowa is, this flat pancake, so that we have to worry about things like terrain and elevation, but that turns out not to be true, and that there's some very strong and strong terrain effects that happen in the state, including in a place like Decorah. Now, if you've ever been to Decorah, you know that Decorah is kind of down in the valley. The airport station is actually up on the hill outside of town, and so there's actually can be quite a large difference between the two. Another one that happens a lot is Dubuque. The Dubuque airport, again, is outside of town and up on the hill, whereas some of the weather stations in Dubuque are down along the river in the valley and below the bluffs. And so those differences can be pretty large if you do things like growing degree days over a period of time. So in this case, we again there's the 2012 value for Postville. And so now we have accomplished our task, and we can go on to our next one. Soil temperatures. Popular product on the website is a soil temperature map that I do that is nice and colorful and shows the counties and a lot of data on that. But I want to show you how to get to that and what you can do with that map. And we'll also download raw observations from the ILC Soil Moisture Network that went into that. So again, we're going to go back to the website. This tool, or this map, is actually one of the most popular ones. And so if you scroll on the bottom of the page, you actually will find it right here. And all you have to do is click on it. And we get to a map that the main landing page, the default to show is the last 3 days of analyses. Now let me explain what's going on in this map. So we have Iowa State soil moisture stations out the ag farms. They're measuring soil temperature. They measure it every 5 minutes actually. But that data is noisy because, of course, the sun heats the ground and it causes variability in the ground, which we don't really necessarily care about. An average value for the day can be useful to know what a planted seed or whatever you're concerned with in the ground is experiencing in bulk for a given day. Now, some questions come why do we pick 4 inches? For those of you who remember, we used to plant corn much deeper than what we do now, so that's one of the reasons that 4 inches was picked. Another one is from a data quality aspect is that putting a sensor at 4 inches is easier to maintain than a sensor at 2 inches. A sensor at 2 inches will drift to the surface pretty quickly. One at 4 inches has a little bit better chance to at least stay at that level for a year or more at a time without getting manually put back there. Things like rain and stuff like that and frost freezes like to heave things out of the ground. Same as the effect with that sensor at 4 inches. I'd also, at 4 inches, it's nice because it's less impacted. It still has a diurnal signal, which means that the sun's heating and the cooling at night, create a large swing of the temperatures. But the value at 4 inches is much more muted than at 2 inches. So again, we have this ability to get a more representative sample of that top soil, and not just something that's at the skin depth, which can get very hot, of course, during the summer times in the day, and even in the winter times when the sun was able to hit it. So there's this map. The links at the top are some various ways to go through downloads and also the archive. So our task here was to find this map, but for earlier this year. So we want to go and look at the archive. This archive takes you to this map in what I call the IEM time machine. And so the time machine is just a simple way for map products to go backwards in time with simple sliders at the top and see this map as it existed in previous years by this top slider. So we're quickly ripping through time and code iterations as I change things on the website. You can iterate just through the days of the year. And of course, we want to get back to May 1st of this year. So we just keep going back, June, May, and it settles there May 1st. So there was a map on May 1st. And so we actually have now completed this task. But just to show a little bit more about this map, what you see here is that we're merging together two data sets. The gridded and pixelated sort of detail you see on this map is coming to us from a weather model. It's analyses. The red and bigger numbers on the map are coming from actual observations. And then the smaller numbers that you see at every county is basically a grid sample from that modeled data that has been bias corrected by the observations. So we're able to hopefully merge the two nice worlds here of having a high resolution depiction of soil temperature, but also being it based in reality to observations. The simple fact is that sometimes weather models will drift, particularly with soil parameters in their analyses. And so we just need to keep those in line with one with another. Now, this isn't necessarily a forecast model, so we don't worry about the down things you can have with modeling the future, but this is just an analysis that the weather model produces that we sometimes refer to as the truth, because it doesn't have any forecast component to it. So anyway, what I'd like to do is go back and to let's see if we just let's go back to the home page and back down to this tool. I'm going to go to the observation download. So this is the place that you can get the raw data that went into that map. And so what you see on this page is a bunch of selection options for which stations you want to download for. And so in this case, we're just going to pick the Ames station west of town. You can pick a start and ending date for whatever time period exists for the station. We'll pick May 1st to October 1st. And then the various daily variables that are available for this station. And we want to look at the daily average 4-inch soil temperature. There's a whole bunch of other variables that are available, including some specialized variables that exist for just only the vineyard stations. There's also some data that exists for a certain newer type of a soil moisture probe that we're testing right now. But we want to download those in Excel format. And so when we get the data, now we have an Excel file called isusm.xls. Let me click on it. And it's loading. And there we are. There's all the daily temperature observations for that station. And with that, we have completed another task. And so we're rolling right along. We found the map on May 1st, and we downloaded the raw observations for it. Next task, solar radiation. Now, some people particularly in the ag sector, have an interest in the solar radiation data. I suspect that for most crop consultants and others like that, this is probably a variable that they don't necessarily have a lot of comfort with. And there's a lot of reasons why this is a tricky variable. For one, it's sort of expensive to observe. You have to have good equipment to do it. And that equipment needs to be well maintained. And the data from it really is more or less limited to research people that want to do modeling and stuff like that. But, some folks that are weather savvy might have other uses for it. But all this data is available on the website, so there's nothing as far as we try to protect the public from seeing it, but it is available. Now, the only observations that we have of this data is from the ISU Soil Moisture Network. But and the field notes go in this topic a little bit more as well. I do produce an analysis for solar radiation estimates coming from model data, and pair that with the National Weather Service co-op sites. And so the task today is to download this data from the co-op data, but also look at the observations from the soil moisture network. So let's see if we can do that for task 5. All right, so we're gonna go back to the home page. And our task here was to download the co-op data. So we're gonna go to networks to the co-op. At the top here, it delineates between 2 data sets. One is the co-op data, which is the raw observations from the National Weather Service. Another one is called the IEM value-added ClimaDat data. So this is where we're trying to get at what actually is ClimaDat. And so this is the co-op data with some value add that I do to it. And so we want to download from this value-added data. So now we get into a data portal for download from data from the cooperative network or ClimaDat stations. So we have a whole bunch of ways that we can pick stations from of what's available. And in this case, again, we find Postville. And so the trick here is once you select a station is to add it to your selected stations. And so by doing that, we get it down into the selected stations column. And these are now what you're going to get for a download. We can again set a period of time. We're going to do 2012. Actually, we'll go back and do let's do last year, 2011. And you watch me struggle with my own forms. We'll get it done here. And we'll do May 1st, and we'll do through October 1st again. Now, the neat or confusing part here is we have this variables section where you can pick from what's available. Now, what I try to do here is delineate between what's being computed, like, for example, growing degree days, which I do compute ahead of time for you if you just want to not have to write your own equation in Excel to do it. You can get them directly here. Or variables that are actually observed, like high and low temperature and snow data. But there's also options here about these estimated solar radiation data sets. And so these 3 ones that, and again, the field notes goes into these 3, but the one I'm going to focus on today is this MIRA one, which is a data set coming from NASA, and it has a good quality. Well, so I select that as the data variable one to download. I would also point out while I'm here, since I have the floor, is that there's a specialized section here for data formats. And so one of the things you can do on this website is download this data, but in a specific format that's built for a given model. And so people that are using AppSim or the Sentry model or DNDC or Salus, or I think Daily Daycent is another one there. I see you can just click that option, and then it sort of overrides everything else on the page and gives you a data file that you need to run that given model for that given station. Well, we're not going to do any of those today. We just want to use Excel because we love Excel, right? That's where we pick Excel. And so these other ones, we're not going to care much. We can also include a lat lon if you want in the download. This last option on this page is sort of technical, but sometimes if you have a modeling situation or you want to do some scenario work, you actually need to have data for the whole year. For example, if you're sitting here at May 1st, 2022, and the future let's just do next year, May 1st, 2023, and the future hasn't existed yet, your model might actually need data, to make a forecast or to go out in time and basically to get you an answer at the end of the year. So what you can do here is you can replace a previous year's worth of data in lieu of what doesn't exist for the current year. So that's a neat way to do a scenario where you say well, last year you could have said, well, on May 1st, let's take the drought year of 2012 and replace all and put that in place of what doesn't exist in the future and see how that works out for a forecast. So that's kind of technical, but some people do use that quite a lot to do this sort of scenario work. So we download it, and so now we have a file that has the data for Postville for 2011. I got an additional day of the year column that's because some modelers like that. But there's the MIRA solar radiation daily data in megajoules per day. And we've completed this task or this subtask. The other part I want to do today is to show how to make a map from this data. So we need to go back to the website, and we're going to go again to the home page. Now this map, chart, we're going to make a chart of the daily solar radiation data. And so in this case, what I want to do here is go to the network section and go down to ISU soil moisture, which is the main page for the soil moisture network. It takes you to a landing where it shows you, today's ugly radar presentation where we have a lot of snow and blowing snow, current temperatures, whatnot. But we're focusing on here on the plot time series option. And so here when we go to the plot time series, we have a bunch of different pre-generated options that you can do to generate a plot for a time series of your time period of your choice and for a variable of your choice. And in this case, we're going to pick the daily solar radiation. And again, we'll pick a significantly long period of time. And we click the make plot and then we chunk. And there we go. We get a plot of daily solar radiation from the egg farm station west of town. Now, this particular plot you might wonder what this black line is. This is sort of like a model-based theoretical max based on a coefficient in the atmosphere, whatever. It's basically what could you expect for a max value for a given day if everything was crystal clear in the sky and you didn't have any scatterers or anything like that. So I think we've completed this task and we're doing good on time. So hopefully we're gonna have time for some fun at the end too. Task 6, IEM auto plotting. So if you're on the Twitters and the social media, whatever, or you see presentations, you often will see, sometimes, I should say not often, but sometimes you'll see a content coming from my website. You'll see my nice IEM logo, but it's some sort of generated chart. And so what I'm trying to do here is I'm trying to reduce friction for people so that they don't have to download an Excel file, and they don't have, because if you notice, when I downloaded these Excel files, I never actually tried to make a chart from them because it's tough for me to make charts in Excel, and I never do it. So, but I can't imagine for most people in the world that they don't want to be in the business of being an Excel chart master. So I try to make a website that can generate these charts for you, and you just download the image and put them in a presentation or whatever you want to do. So I'm going to go through an example here with the IEM auto plotting system to show you how to generate a chart of El Nino 3.5 index and some statewide variables. So again, we're at the home page. This is one of my most popular things. And so it's over in the most popular section, automated data plotting. And so we get here, and this is the craziest data portal that on the website. The amount of functionality here is way too much, but it's fun. But just to briefly give you an introduction to this auto plotting section, auto plotting section is organized into plot types. And so right now there's like 230 different plot types on here. And if you doom scroll this page, what you'll see is an example image for each of these different plot types. So you see all sorts of wide, plethora, or whatever fancy other word you're going to use for describe. Look at all these fancy different colorful things, and wow. So hopefully you either can remember what type of plot you saw before, or you can scroll down through here and say, oh, this plot looks something like familiar, something I saw before. And then you can click on it and go into the portal that generated it. Another option, I should say, let me click on one of these, for example, is that if you look at the auto plot that gets generated on a website or something like that and look down this corner, you'll see it say IEM auto plot 51. And so that's the magic key to where this came from. And so you can either, with that number 51, you can either go up here to the select chart type and type in 51 and get it, or you can go up here to the magic search bar and put 51 in, and magic, it comes right back here. So if I put in like 97 is another neat one that people use. I put 97, there's 97. So that's one way to get to them. Another way is if you go again to search bar and you start typing in some text. And so I'm going to type in Nino and see what I get. So I get two options here. First one says monthly precipitation with El Nino SOI index. The other one says monthly station departures and El Nino 3.4 index. So this is kind of fun, but we want the 23rd one here. So this auto plotting, we select the plot type, and now what gets generated is an interface where what we can do to control what's on that plot. And so one of the things, the first thing we get here is an option to select a station. We can do this for other states that we have data for. But in this case, what I want to use here in this case, and I'll explain the science as to why, is I'm going to use the Iowa aerial average value. So if I start typing in Iowa there, I get to this identifier IA quad zeros Iowa average. And so what this is I, through a grid analysis mechanism and some zonal statistics, I end up creating a statewide average value for precipitation and temperature. Now, on a daily time scale, these can be sort of not very useful for use, but on a longer scale, like monthly and yearly time scale, these can be very informative. And so in this case, I picked the Iowa average, and for a variable, I want to pick total precipitation. And I can say make plot with options. And look what we have. We have a combination of monthly precipitation departures for a statewide average value for Iowa, expressed over here on the left-hand side in inches. And the black line is the Nino 3.4 index with negative values indicating La Nina and positive values El Nino. And so it's kind of fun to look at these. Of course, there's no exact one-to-one relationship between these two, but many times they inform the El Nino index. The Nino index informs what's going on in the state. In this case, if you remember back in the 2015, 2016, we had what was called the Godzilla El Nino, which basically goosed our average temperatures up. And I can show that in just a little bit. We can make this plot for temperatures. But now we've been in this persistent La Nina, either we want to call it 1, 2, 3, triple dip, or I think we're almost going to a quadruple dip now on La Nina. And you see what's interesting is that the precipitation departures have become quite negative or drier than an average. And that's a pretty strong signal from a La Nina situation to have below average precipitation. And just so while we're here and having fun, we can make a plot for the average high temperature too, departures. And again, these big positive ones here early in this period were associated with the Godzilla, again, El Nino situation. But as you go out in time here, the relationship necessarily is more seasonal. But the other thing I want to point out here, though, what you can do while you're on these auto plots is that below it, there is, again, an option to download this data. And so we're going to pick on our favorite Excel again. Now, all of a sudden, we've got that data file with the monthly values for average temperature, average high, average low, precip, departures, and then the Nino 3.4 index. So you can then take that chart and do what you wish, or, of course, you could always, right-click this chart and says save image as, and save it to your desktop as a ping that you can use in a presentation, or you can generate this image as a PDF if you want to do more higher resolution printing, or a scalable vector graphic if you want to do, again, some more design stuff with it. That's a capability. So that is the auto plotting capability that we have here. The other thing I want to point out while I'm looking at this, or while I'm pointing out this, is that oftentimes with my daily feature of the day, I'm going to go click on the past features, you will find some chart that's talking about something, but then you'll see this link to generate this chart on the website. And this is almost always nowadays coming from the auto plotting system. So if you see a plot that looks neat, for example, this is a partitioning of the daily high temperatures for Des Moines, you can click on this link and it'll take you to the autoplot app with all the settings the same to generate that same image. So you can take that image and say, oh, that's neat. But this was for Des Moines. And again, we care about post-fill. So we're going to switch this to post-fill. Type, Daryl. Post-fill, make plot. And now all of a sudden we have that same plot that was for Des Moines, but now it's applied to our local area in post-fill. So exciting. Keep going. The next one is we're going to talk about NWS warning information. Now, this is sort of an interesting data set, and it's a unique one that the IM website has. For whatever reason, you can't find this stuff on Weather Service's website, archives of it, or even at the National Climatic Data Center. But in this instance, I'm going to give you a real example. So perhaps you had some farm or some area that took damage at a certain location, and you need to find more information about what the Weather Service had going on at the time, as far as warnings going on and what sort of reports they got. So in this case, I'm going to have an event that actually happened where they took a little bit of damage on June 28th, 2017, and we'll go and try to find some data and plots for that. So back to the website we go. And again, if we're used to it, we're going to click on the IEM to go to the main page. In this case, we're interested in NWS data, which pulls this down, and we're going to be looking at searching for warnings. Now, this tool has a lot of capabilities and technical details that I won't get into, but the simplest thing to do here is to drag this little icon over to where my mother's farm is, somewhere in here. And what it does is it goes and searches through the archive of warnings that I have, and it produces all of the warnings that were valid for that location. In this case, we're interested in an event from 2017 and then June. So if I just start typing in some text, it filters out this display, and we find a tornado warning for that afternoon. And so what you can do with this tornado warning is if you click on the little link here for the event, it takes you into this massive data portal for this particular tornado warning. And so we find just a simple image of the warning, stuff you see on TV and with the little polygon box, a presentation of a ugly looking radar display at the time. But we have some different portal options here for what tools available for this particular warning, including the raw text. Now, some of you may have never seen raw text before for a weather service tornado warning, but this is what it looks like, and we have a very good archive of it. But you can read down through, 10 miles north, severe thunderstorm producing a tornado near Monona, which is just north of where the farm is, moving east at 45 miles an hour, where it's going to be, some locations in this thunderstorm, St. Olaf, which is nearby. But you can then see how this product was issued and then any updates they made to it. Tornado warning remains in effect. It's radar indicated. And then then finally the expiration statement for this. So that's on the text data tab. You can send it to your printer you want, or you can just download it if you want. The interactive map allows you to go and look at the radar information in a little bit more detail. But then it also then starts pointing out or showing these little icons for damage reports they got. So you can click on it and get more information. So 2 west-northwest of Farmersburg. This is very close to the farm. Here's trees down. So this is a report that the Weather Service got. And here's another wind report that they got. Numerous trees down. Time estimated from radar. So the other tabs just sort of rehash that storm reports that they got. And so there we found some information about the warning. But then I guess one more thing I want to show in the interactive map part is that you can step through the radar as it goes on too. So again, sometimes what ends up happening is that sometimes you might be, as an agronomy type consultant person, you might be in sort of an investigative mode where a farmer might say, well, there was a storm, on this day and I took damage. And for outside of being skeptical at first, you can go into this tool and sort of look for warning events or what the radar presentation was and so on to try to look at what happened on that given day. And this is task 8 before we have a couple of fun ones quick at the end, but we're going to talk about wind roses. I love wind roses. One of the most popular things on the website, I keep saying that word, but this is one of the most popular ones, and it's a unique one, is the ability to generate wind roses. And wind roses are cool. They're a little bit technical, but for those of you that understand histograms, they're basically histograms. So we're going to go to the home page. We were interested in Decorah, so we're going to pick on Decorah here. So station data, metadata. There's Decorah. Select station. So now we're into Decorah's data sort of portal. And the two ones here I want to point out is this Wind Roses tab, a button, and this Custom Wind Roses button. So we're going to go first to the Custom Wind Roses one. And what we were able to do here is we're able to pick a period of time. And I mentioned I want to do June 14th of this year. So we got 2022 and then June 14th. And we'll go to June, we'll do 15th, 12 a.m. to 12 p.m. or 12 a.m., 12 a.m. So it's a full day's worth of data. There's a whole bunch of convoluted options here, what to pick it and so on and so forth. But we will select that. And what ends up coming up is what's known as a wind rose. So the wind roses, in this case, we call it a meteorology wind rose because you're supposed to envision yourself sitting at the center of this chart. And these bars represent wind that's coming at you from that direction. So meteorology has the concept of a south wind, meaning a wind that's blowing from south to north. So if you're sitting here, you sort of imagine these bars coming at you. The color of the bars represent wind speed. So in this case, we're delineating wind speed reports in miles per hour between these certain thresholds. And the orientation indicates the direction. So this is a southeast wind, a south wind, a south-southwest wind, and so on. So in this particular day, what you see is that this was a windy day. because you see there are some reports here up in the highest levels in the 15 to 20 miles. That's a pretty strong steady state wind. That's a pretty strong wind. Um, but then also a lot of reports here in the 10 to 15 miles an hour range, and even a lot more in the 5 to 10 mile range. So this is a windy day. And so the obvious application for this is spraying. So how do you use this for a spraying application? Well, you can just look at a particular event and see, and then you could put this time interval tighter, like during the daylight hours, or if you want to just pick, let's say, the morning hours. So we're going 8 a.m. to 12 on this day. So we're seeing a much smaller data set now. Actually, I'm sorry, I screwed that up. I need to go back and put this the 14th. I was wondering because you saw these data points show up here. I'm like, why did they show up? But that was because they were from the next day. Anyway, there we go. So now we got there's only 8 observations for this period, but you can see they're all pretty strong and from the south. And so in this case, you say, well, if you're dealing with a drift issue or something, at least you have an idea of the prevailing wind direction during this period, and then some estimation of how windy it was during that period. So these are the custom plots. What I also want to show is if you go one button back and look at what's known as wind roses, these are the ones that are pre-generated and that show a wind rose over a long period of time. In this case, it's period of record, and one's broken down per month. So January, February, March, so on and so forth. Now this glip that's showing up here at north is something I sort of need to fix on. It's a complicated reason why it's there, but it's not real. So I'll get this fixed anyway. But you see different characteristics of the wind, for example, in the winter cold season versus in the summer season, what the prevailing directions are. And so these things can be useful for doing things like sighting. For example, if you, in this case, this is for a full year, and let's say you were trying to put some hog confinement up or something like that, an obvious thing that this plot shows is that if your hog confinement is to your northwest or to your southeast, that's sort of like the main directions of where a lot of the dominant wind flow is in Iowa. And so if you want to be oriented, usually the best one is northeast. Now the caveat, of course, is that you can have some really bad inversion days on the northeast where the smells can be very horrible. So we're not going to get into that today. Maybe I'll have another Crops TV where I talk about odor transport. But anyway, so that was that task. And now we're ready to have some brief fun. I got a few more minutes, I hope. And so let's do a fun task for Webcam Archive. So the IAM website has a humongous amount of weather webcam data that you can go and see. So I'm going to go back and look at how bad was the blizzard of February 4th, 2011. So how do we do that? So back to the website we go. We click on IEM. We go to webcams this time, and we go down to IEM webcam viewer. In this case, we get a portal that shows all the various webcams this is current data right now as I'm recording this, of course. And we have the mashup of different Iowa DOT truck cams. So we can look around. Wow, look at the difference, between northern Iowa and there. But I'm geeking out here where I shouldn't be. We need to keep on task. So we're going to archive. Now we want to set this guy to 2021, February 4th. There we go. So that's all the radar and webcam data that we have available for this day, including the DOT truck cams. And so here we go. So we can go back and look at, some wild and crazy situations. Now, so the webcam, when we first started webcams like 20 some years ago, I started this skeptical thing like, webcams, what sort of good environmental data is this? But it turns out that having archives of webcam data is gold. It's literally gold. Because you can go back in time. Again, we're talking about this spraying situation or whatever situation was, and you say, well, what did it actually look like visually outside at a given time of the day and various locations? And so this tool is a way to go through this archive and go back and look at, what were the roads like on a certain day, or was the sky raining? Like, let's just pick a rando day. Let's go back to August 18th, and we'll leave it at noon. And so we see what's available, and here we go. So there's some of the webcam imagery from a roadway weather station alongside a road. This is a webcam that a TV station has in Humboldt, I believe. Some more that were here's Waterloo. There's the Unidome. What did the Unidome look like on August 18th, 2011. Anyway, so the opportunities here are endless. The bit of functionality I want to show on this one is just the ability to, you can turn off these layers if you don't want to see them because the map can get cluttered. Oh, I also want to point at the YouTube channel. If you're into YouTube, you can look at my Icarus channel, and I have like 400 some time lapses of cool videos. And since I have the floor, let's do that quick. If we go to webcams and then cool lapses, I link to my YouTube channel, but you can just, you can play these cool lapses of convection, and a lot of these have a lot of useful teaching education aspects, and these are all public domain videos that you can download and use as you wish. Some of them are more glorious than others. This was a fun one from the ag farm when we had a bad blizzard, and I got all kinds of plowing equipment stuck. These are really neat ones. Very strong convection. This is a illustration of radiative processes of trees, and so we're getting down into the woods here, or the weeds, and we don't want to be doing that. Let's have one more fun task. We're almost done. High resolution precipitation maps. So this is kind of not necessarily as fun, but it's neat that you can do this. And so I want to show you how to do this. So this is an auto plot capability. So we're going to go back to the home page. And we're going to go to auto plotting. And the tool we want to look at here, we could search for precipitation, but save a little bit of time. I'm going to pipe in MRMS. That was one of the big rain events that saved the crops in certain locations in the state. So that we're going to pick on a zoom location for a given county. And so in this case, we want Winneshiek County. And we want to pick a date period of, what did I say, August 27th? And you can just do it from the pull down menu too, I guess. August 27th. And chunk. This one can take a little bit of time because it's a lot of data to have a look through, but there we go. So now we have this special high resolution rainfall based on radar information map that's zoomed in. Again, we're sort of interested in post flow in this area, and that is that for the website. We could also produce that, over longer time periods of time, but we will leave that as an adventure for the reader. And we are done. Just to emphasize, please email me every question, every little concern, every idea you have. Email me. I'll respond, except for times when I'm giving seminars like this, I can't respond, but I'll respond quickly in most time. And I'm on the Twitters. I appreciate the time here, and I hope you had a fun time.